Dear students, in previous class we discussed about the conditionally and absolutely convergence of a series. A series sigma xn is said to be absolutely converges if sigma mod xn also converges. If sigma xn converges and sigma mod xn does not converges, then that series is said to be conditionally convergent. Okay. Then we also prove that absolute convergence implies conditionally convergence, and reverse inclusion need not be true. Now consider a series. Let x equals sigma xn. Here sigma xn equals sigma minus 1 power n plus 1 by n. Consider the series. So if you expand this term, what do you get? When n is 1, it is 1. When n is 2, it is minus 1 by 2. So plus 1 by 3, minus 1 by 4, plus 1 by 5, minus 1 by 6, plus etc. Okay. Right. 1, 2, 3, 4, 5, 6, 7. When n equals 1, it is 1. When equals 2, minus 1 by 2. So it is an alternating series. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus etc. Okay. So later this can be grouping as, suppose 1 minus of 1 by 2 minus 1 by 3. Again minus of 1 by 4 minus 1 by 5 plus 1 by 6 minus etc. Agree. Let y1 equals 1, y2 equals minus of 1 by 2 minus 1 by 3. Clear? Let y3 equals minus of 1 by 4, minus of 1 by 4, minus 1 by 5, plus 1 by 6, and so on. So we have a series, another series, sigma yk. Okay. So the sigma yk is obtained from the sigma xn. How? Sigma yk is obtained from sigma xn. How? Leaving the order of the term xn fixed but inserting some of the brackets. Okay, sigma yk is obtained from sigma xn by leaving, the order of the term fixed in xn and inserting the brackets. So this processing is said to be the grouping of series. This is said to be grouping. So grouping of series. So what is grouping of series? Grouping of series means that the sigma xn be any given series, then we can obtain another series sigma yk by leaving the order of the term fixed in xn and inserting the brackets, so and that group together finite number of terms. So this process is said to be grouping of series. Means the order of the leaving the order of the term in sigma xn fixed and leaving the order and inserting some of the brackets. Here the brackets are inserted and they form together forms the number of terms. Agree? So this process is said to be grouping of series. Clear? So if a series sigma xn is convergent, then any series obtained from by grouping the term is also convergent. If sigma xn is convergent, then any series obtained from it by grouping the term is also convergent. Means if sigma xn convergent, then sigma yk is also convergent, where sigma yk is the series obtained from sigma xn by grouping. Clear? So our result is when sigma xn converges, then sigma yk is also converges. How? So its proof is that the sigma xn converges Sigma xn converges means it's a partial sum. This is a partial sum. Let Sn be the partial sum of the series sigma xn. Then when sigma xn converges, then Sn also converges. Okay. So when sigma xn converges, let yn or let sigma yn be another series obtained from sigma xn by grouping. Listen, our requirement is when sigma xn converges, then the series obtained from sigma xn by grouping the term is converges. So let us first suppose sigma xn converges. Let sigma yn be the series obtained from sigma xn by grouping the terms. So assume y1 equals x1 plus x2 plus etc. plus xk1. Okay. What is y2? y2 equals xk1 plus 1 plus etc. plus xk2. Clear? Let Sn be the sequence of partial sums of sigma xn, be the sequence of partial sum of sigma xn, and let Tk be the sequence of partial sum of sigma yk. Okay. Then what is T1? Here T1 equals y1. So Tk be the sequence of partial sums of yk. So what is T1? That is y1. So what is y1? y1 is x1 plus x2 plus etc. plus xk1. But what is Sn? Sn be the sequence of partial sums of sigma xn. So y1 is x1 plus x2 plus etc. plus xk1. That is it is sk1. Clear? So T1 equals y1 equals sk1. Clear? What is T2? What is T2? T2 equals y1 plus y2. That is the partial sum. Tk be the partial sum of sigma yk. So T2 is y1 plus y2. So what is y1? sk1 plus what is y2? sk2. So sorry, this one. So x1 plus etc. plus sk1 plus sk1 plus 1 plus etc. plus sk2 is nothing but what do you get? sk2. So T2 equals sk2 and so on. Agreed. Similarly, what is T3? So in the preceding same line, we have T3 equals sk3, etc. That means what is Tk? That means Tk be a subsequence of Sn. Clear? T1 is sk1, T2 is sk2, T3 is sk3, etc. So Tk be a subsequence of Sn. What is Sn? Sigma xn convergent. Sigma xn convergent and secant Sn being an n partial sum of sigma xn. Therefore, surely secant Sn convergent. Since Tk be a subsequence of xn, that should implies Tk convergent. What is Tk? Tk be the partial sum of the series sigma yk. Therefore, sigma yk converges. That means the series obtained from an original series by grouping the term is always convergent when the original series is convergent. That's our conclusion. Means sigma xn converges, then the series obtained from sigma xn by grouping the term, if it is sigma yn, then sigma yn also converges. Clear? Yes. What about its reverse inclusion? When sigma yn converges, sigma yn be the sigma yn or sigma yk, whatever may be, which is the series obtained from sigma xn by grouping the terms. When sigma yn converges, do you say that sigma xn converges there? So for say an example, consider sigma minus 1 power n plus 1. What is minus 1 power n plus 1? This equals 1 minus 1 plus 1 minus 1 plus etc. Okay. What about this alternating series? This should be diverges. Why? Because two of the subseries, 1 minus 1, 1 minus 1, etc. that should always converge. The sequence 1 minus 1, 1 minus 1 always diverges. Why? 1 minus 1, 1 minus 1, 1 minus 1 always diverges because 2 of the subsequences are converges to different limits, hence it always diverges. So sigma minus 1 power n plus 1 is diverges. Then grouping the term is grouping. Let us sigma yk equals 1 minus 1 plus 1 minus 1 plus 1 minus 1. This should be converges. That converges to 0. So when sigma yk converges, even though sigma yk converges, sigma xn does not converges. Means the series obtained from an original series, if the series obtained from the original series by grouping the term is convergent, it need not be implies the original series is converges. But when the original series converges, then the series obtained from that original series by grouping the term is always converges. Clear? Okay. Now consider a harmonic series. Consider the harmonic series. What is the harmonic series? Sigma 1 by n. What is sigma 1 by n? 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus etc. And we see that sigma 1 by n always diverges. Now this is a rearrangement of the series. How to rearrange? This can be rearranged as, this can be rearranged, means the elements are fixed, but scrambling the order. It is 1 by 2 plus 1, 1 by 2 plus 1, plus 1 by 4 plus 1 by 3, plus 1 by 6 plus 1 by 5 plus etc. What are the elements in that series? Sigma 1 by n is 1 plus 1 by 2 plus etc. And you can scramble the order by keeping the element fixed and scrambling the order, then you have another series. 1 by 2 plus 1 plus 1 by 4 plus 1 by 3 plus etc. Here interchanging the first and second term, third and fourth term, fifth and sixth term, etc. You can obtain, means the second series is obtained by interchanging first and second, third and fourth, fifth and sixth terms in the original series. Okay. So this processing is said to be rearrangement of the series. This process is said to be rearrangement, not a grouping. Grouping is by inserting some brackets and grouping the term. Here rearrangement of a series means you can keeping the elements fixed but scrambling the order. Or you can make another one, another series from the sigma 1 by n. How it is first order term 1. 1 means 1 by 1 or 1. It is 1 plus first order term, next term. The even terms, which are the first two even terms, 1 by 2 plus 1 by 4. Next the order terms, 1 by 3 plus 1 by 5 plus etc. It is another series, but the elements are fixed, but the order is scrambling, order is changing. So you can prepare number of series from a given series by scrambling its order. So this process is said to be rearrangement, and the series are said to be rearrangement of series. So this is a rearrangement of a series. Means a series sigma yk. Rearrangement means a series sigma yk in R is a rearrangement of the series sigma xn. If there exists a bijection, f from n on to n such that yk equals x f k. Yk equals x f k for all k falling n. Okay, yk equals f x k. So there exists a bijection from n on to n such that yk equals x f k means here the elements are fixed but the order is scrambling. Clear? Yk equals x f k where k is in y1 x f of 1. What is f of 1? Fixed. Y1 equals y2 xf of 2, this one, and so on. So now we already see that when sigma xn converges and the series obtained from sigma xn by grouping the elements is also converges. So what about the convergency of the rearrangement series? That theorem is known as rearrangement theorem. The rearrangement theorem states that let sigma xn is absolutely converges. Not only converges, it is absolutely converges. Absolutely converges. Not only conditionally, it is absolutely converges in series in R. Then any rearrangement series sigma yk of sigma xn converges to the same value. Here, sigma xn is absolutely converges. The absolute convergence is the crucial point here. Sigma xn be a series, given series that is absolutely converges. Then the series obtained from sigma xn, that is sigma yk, by the rearrangement of sigma xn, then sigma yk converges to the same value that of sigma xn. How? The proof is, so in grouping theorem or in grouping of series, there is only the convergency, not absolute convergency. When sigma xn converges, sigma yn also converges. Sigma yn is obtained from grouping the terms. But here sigma xn absolutely converges, then sigma yk converges. There is a difference. So rearrangement theorem is an important one. So how to prove this one? Sigma xn converges in R. It is given. Let sigma xn absolutely converges. Sigma xn absolutely converges. Absolutely converges means sigma xn also converges. That means sigma xn converges. The sigma xn converges in R. Sigma xn converges in R, or sigma xn converges to some x. Sigma xn converges to some x in R. Sigma xn converges in R, or more precisely, sigma xn converges to x in R. Okay. Let Sn be the sequence of partial sum. Sn be the sequence of partial sum of sigma xn. Let Sn be the sequence of partial sum of sigma xn. Then when sigma xn converges to x in R, this should imply Sn converges to x in R. Okay, Sn converges to x in R. That means for all epsilon positive, there exists some k1 falling n such that modulus of Sn minus x strictly less than epsilon for all n greater than or equals k1 by definition of convergence. Okay. Again, sigma mod xn converges. Why? Because of the absolute convergence. Sigma mod xn converges. That implies for all epsilon positive, there exists k2 falling n such that modulus of xn plus 1 plus modulus of xn plus 2 plus etc. plus modulus of xm or x cube, whatever may be, x cube for all n, okay, x cube strictly less than epsilon for all q greater than n greater than or equals k. Why this? That is from Cauchy's criterion. Okay. So when sigma mod xn converges by Cauchy's criterion, modulus of xn plus 1 plus xn plus 2 plus etc. plus mod x cube strictly less than epsilon. So let n equals maximum of this k1 k2, then these two equations are held for n greater than or equals n itself. Okay, that means sigma k ranges from n plus 1 to q. Here it is sigma k ranges from n plus 1 to q mod xk strictly less than epsilon for all q greater than or equals or q strictly greater than n. Okay, strictly not greater than or equals q greater than. Okay, so strictly greater than n. Agree. Now let tk be the sequence of partial sum of the series obtained from sigma xn by the rearrangements. So let Tk be the partial sum of the series sigma yk. Let m fall in here. Let m is a natural number, capital M be a natural number, such that x1, x2, etc. xn, the terms x1, x2, etc. xn are contained as summed in Tm, equals, what is Tm? y1 plus y2 plus etc. plus ym. Okay, what is T1? Tk, Tk be the sequence of partial sums of sigma yk. Let m is any natural number, then the terms x1, x2, etc. xn that contains as summed in Tm, where Tm is y1 plus y2 plus etc. plus ym. Hence, if m greater than or equals m, if small m greater than or equals m, comma, here Tm minus Sn be the sum of finite number of terms of xk. Tm minus Sn be the sum of finite number of terms xk, where k greater than n. So what is Tm minus Sn? Modulus of Tm minus Sn. Modulus of Tm minus Sn equals sigma k ranges from 1 to q modulus of x. So k ranges from not 1, n plus 1 to q. N plus 1 to q, k ranges from capital N plus 1 to q modulus of x. K ranges from capital N plus 1 to q modulus of x. Agree. So for m greater than or equals, for all m greater than or equals n, what about the modulus of Tn minus x equals modulus of Tm minus Sn plus Sn minus x. So it is less than or equals, by triangle inequality, it is modulus of Tm minus Sn plus modulus of Sn minus x. Strictly less than epsilon by 2 plus epsilon by 2 means epsilon. So modulus of Tm minus x, what is modulus of Tm minus x? Thus modulus of Tm minus x strictly less than epsilon. Finally, modulus of Tm minus x strictly less than epsilon. That means Tm converges to x. Tm, what is Tm? Tm be the sequence of partial sum of sigma yk. Hence Tm converges, therefore sigma yk also. That means, that implies sigma yk converges. So this is the rearrangement theorem. The theorem is important. That is, when sigma yn, sigma xn absolutely converges, then the series obtained from sigma xn by rearrangement of sigma xn, that also converges. The absolute convergence is the crucial term. Okay.